والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the second lecture in section 8.1, which is about estimating the population mean. We have seen that the point estimate of mu is x bar, and if sigma is known, the confidence interval is given by x bar, which is the point estimate, plus or minus z, which is the critical value, times sigma over square root of n, which is the standard error in that case. Now, if sigma is unknown, okay, then we can use S to estimate sigma. So the standard error would be in this case S over square root of n, because we don't have sigma. But that's not the only change. The main change here is the critical value. The critical value is not going to be a z value. It's not taken from the standard normal table. If sigma is an unknown, it would be a t value. So it's a t value. And the t value will be taken from the table of the students' t distributions. Notice that we say distributions because really we have a family of distributions. All of them are bell-shaped and symmetric, like the standard normal distribution, but with greater area in the tails, so more spread than the standard normal. Each distribution in the T family is defined by its degree of freedom. So for each degree of freedom, we have a T distribution. The degree of freedom is denoted by df, and it is defined by n-1, where n is the sample size. So if the sample size is 10, then the degree of freedom would be 9. If you want to change from x bar to t, you can use this formula now where s is there. So whenever you have s, we use t, which is taken from the t distribution. There is the assumption here to use the t distribution. The population should be normally distributed. So we should have normal populations. If the population is not normal, at least it has to be reasonably symmetric. So if it is reasonably symmetric, we can use the t distribution. This is the t table. And here we will have probabilities inside for areas under t table, under t distribution curve. So here inside the table, we have the t values. So these are not the probabilities. We have the t values inside the table. And this is different than the standard normal. Inside the standard normal, we have the probabilities, while inside the t table here, we have the t values. The degree of freedoms are here. So for example, if n is 10 and the degree of freedom is 9, you can look here, you can search in this row, and you search for the confidence level. So the confidence level is given here, 0.8, 0.9, 0.95, 98, 99. So you get the confidence level from the question and the degree of freedom, which is n-1, and you take the t value from here, from inside the table. This is the shape of the t table when the degree of freedom is 5. If the degree of freedom increases, it becomes narrower somehow. And when t is infinity, when degree of freedom is infinity, it will coincide with the standard normal distribution. So if the degree of freedom is infinity, we have the standard normal distribution. So this row, the last row, is the Z row. So these are Z values. The last row in the T table, Z values. You remember when the confidence level is 0.95, you put the area, you divide 0.95 by 2, you look inside the normal distribution table, and you find 1.96. So here it's given in the last row. So if you have the T table, you can use the last row to find the Z values if you like. Uh, there is this is a comparison between the T distribution and the standard normal distribution. Both are bell-shaped. There is only one standard normal, but we have different T distributions. For each degree of freedom, this is a T distribution different than this. So we have many T distributions, and the T distribution is more spread. So sigma is not 1 in the T distribution. What would be the confidence interval? It would be x bar plus or minus t, where this is the critical value now. It's a t value taken from the t table. Once you have the sample size n minus 1 would be the degree of freedom, and you find the confidence level and find t times s over square root of n. Sigma will not be given. Sigma is unknown. If sigma is known, you should use sigma and z. If sigma is unknown, you use s and t. That's the difference. So let us solve, for example, one exercise. The distribution of overtime hours per week for employees at a manufacturing company is normally distributed. So it's normal, the population. The time is normal. A random sample of n equals 10 employees is selected, producing a sample mean. So this is x bar, and a sample standard deviation. So this is s. So sigma is not given here. What is given is s, the sample standard deviation. It's 1.3. Based on this information, construct and interpret a 95% confidence interval estimate for the population mean. So sigma is not known, so the formula is x bar plus or minus t times s over square root of n. X bar is given, it is 4.5. We need to find t from the table. How to find t? I need the degree of freedom and the confidence level. The degree of freedom is n minus 1, so it is 9, and the confidence level is 0.95. So we go to the table, and this is 0.95, so this is the confidence level. We look in this row, in this column, and 9 is the degree of freedom, so the number is 2.2622. This is the t value. The t value is 2.2622, isn't it? Yes. So 4.5 plus or minus 2.2622 times s, which is 1.3 over square root of n, which is 10. So it is 4.5 plus or minus, and we can evaluate the margin of error, which is in this case 0.93. And now we can write the confidence interval. It's 4.5 minus 0.93, which is 3 5.57, and 4.5 plus 0.93, which is 5.43. So the population mean, we are 95% that the population mean lies between these. We are 95% confident that the population mean lies between these two values. So all of these example, this example is similar exactly. Here, the data is given. So he said that a random sample of 25 calls, and we want to develop a 95% confidence interval for the population mean. And the value, the data are given. So sigma is not known. So we have to use this formula, x bar plus or minus t times s over square root of n. Now n is 25, but what about s and x bar? You put these numbers in the calculator and you find x bar and s of the sample, and then you use the formula. T here, for example, the degree of freedom is n minus 1, and n is 25. So the degree of freedom is 24, and it's 95% confidence interval. So we can say, we can go to the t distribution to 24. This is the row 24, and 0.95. This is 0.95. So the number is 2.0639. So that's T 2.0639. And once you have from the calculator X bar and S, you can find the confidence interval. So either like this, S and X bar are given in the question. Here, the confidence level is given, and determine the margin of error. Here he is asking about the margin of error, or only the margin of error. The margin of error is E equals, if this is S, then the margin of error is T times S over square root of N. That's the margin of error. So you go to the degree of freedom is 12. You go to the table and find T, the confidence level is given, find T, and S is here, and N is here, so you can find the margin of error. So this question is about the margin of error. Well, let us find T in this case. The degree of freedom is 12, and 98 confidence interval. So 98 is this one, and 12 is this one. So the number is 2.681. So T is 2.681. So 2.681 times 15.68 over square root of 13. This will give you the margin of error. So here he is asking about the margin of error only. We don't have X bar. 11.66. This is the margin of error. When sigma is given, the margin of error would be Z times sigma over square root of N. And you have 99%. So you can, if you like, you can find the Z value, as we mentioned, from the last row in the T distribution. 0.99 is the last column, so it's 2.5758. So 2.5758. This is the Z value times sigma over square root of 25, and you will have the margin of error. So either when he asks about confidence interval for the population mean, he will give you S, and notice here that S square is given. We don't work with S square, we work with S in the formula. فيو need to find the square root of 1.45. It's 1.2. فيو use this value and the formula x bar plus or minus t s over square root of n, because s is given, sigma is not given. Or he doesn't give you s and he gives you the sample. So this is the sample, 12 values. So you need to find x bar and s by the calculator, and then you use the formula x bar plus or minus t s over square root of n if sigma is not given in the question. Look to this question. A random sample of n equals 9 taken from a normally distributed population with a population variance. So the population variance is given. The population variance is sigma square. So I need sigma. So sigma is 5. So sigma is given. And the sample is given. All right. I have sigma. So the formula would be z x bar plus or minus z times sigma over square root of n, because sigma is there. Okay, the sample values are given. We need x bar. We don't have x bar. It's not given in the question. So we find x bar. We add all these numbers and divide by 9. Once you have x bar, you can use this formula to construct the 90% confidence interval. Z is 1.645 in this case. Look to this question. S is given, but x bar is not given. You can find x bar here using this formula. It is summation x over n. So 134 over 10 would be 13.4. So x bar plus or minus t s over square root of n, because s is given and sigma is not there. 0.9, degree of freedom is 9. Find t and find the confidence interval. Similar, this question, okay? Here, sigma is given, so I'm using x bar plus or minus z times sigma over square root of n, and I find x bar by 40.5 divided by 9, summation x over n. Here, I find x bar by summation x over n, and I find s by its formula from chapter 2, the computational formula, summation x square minus summation x all square over n minus 1. So summation x square is given 15472.37. Summation x is also given, n is 27 divided by n minus 1, and you can use the calculator and find s. So here it is important to memorize the formula of the standard deviation. You divide by 26, you take the square root, and the answer is 10.3. So S is 10.3. We need, of course, confidence interval for the population mean. So the formula is x bar plus or minus t s over square root of n. S is, you have s and you have x bar. Find t, go to 26, and confidence level 0.9. Find t from the table and find the confidence interval. Please solve this similarly. And here, let us end our journey by solving this exercise. Car buyers often add accessories to their new cars. A sample of 179 Mini Cooper purchases yielded a sample mean. So this is x bar, this is n, worth of accessories added to the purchase above the $20,000. Suppose the cost of accessories purchased for all minis has a standard deviation. Suppose the cost of accessories purchased for all minis So this is sigma. This is sigma, not the standard, not S, because he's talking for all minis, all the population, not the 179. Calculate a 95% confidence interval for the average cost. So for mu, well, I will use the formula x bar plus or minus z times sigma over square root of n. X bar is 5,000. I need to find 95%, so it's 1.96, the Z value. Sigma is 1,500 over a square root of 179, and I can find easily the confidence interval. Determine the margin of error in estimating the average cost of accessories on minis. Well, this is the margin of error. This is the margin of error. It is 1.69 times 1,500 over square root of 179, and let us calculate the margin of error. It is 189.5. Okay, now what sample size, look to the question, what sample size, so he's asking about n, would be required to reduce the margin of error by 50%. So the margin of error should be reduced by 50%. So the new margin of error would be 189 over 2. So we will have 94.74. So this is the margin, the new margin of error. If you reduce it by 50%, you divide this by 2, you have 94.74. So this is the margin of error. We know that the margin of error is Z times sigma over square root of n. So we have, let us say this is E star, okay? So we have 94.74 equals the margin of error, equals Z. What is Z? It is 1.95 because 95%, so 1.96, sorry, yes, times sigma. What is sigma? Sigma is 1,500 as it is, not changed, over square root of n. And he is asking about the sample size. So if the margin of error is reduced by half, by 50%, what would be the sample size required? Okay, so you solve this equation for square root of n. You can solve this equation for square root of n easily by replacing square root of n or interchanging square root of n and 94.74, the error. So square root of n would be 1.96 times 1,500 divided by 94.74. This is 31.03. And if you raise it to the power 2 to find n would be 963.004, and we choose n to be 964. The sample size cannot be with a decimal, so we always round it up. So the required sample size to reduce the margin of error 50% would be 964. This is the end of this lecture and of section 8.1. Next time we will talk about the sample size.